Hello friends, this is Bharat from Team CP CORP. Today I'll be discussing surface tension as I've said. So surface tension, I'm denoting it with sigma. Now what is surface tension? Let me give you a brief overview of it. What is this? Suppose this is water all around it and this is air above it. Now what are these AB? I have taken molecule A and molecule B. Now first of all focus your attention on this molecule. This A molecule of water, what will be happening to this? Uh, this is all surrounded by molecules. So in water or in any other fluid of this liquid, we got surface tension. All this we have got cohesive forces in between them. So these will be acting upon by a cohesive forces. A will be only surrounded by molecules, so the cohesive forces or the magnitude of cohesive forces will be equal in all directions. Now at B, what we are having is that all the molecules surrounding in this will try to pull this word downward. So there is a net downward motion due to which the molecule on the membrane of the water level can you know apply can anyhow overgo tensile forces. So the layer on the water surface can handle tensile forces. This membrane of water can handle tensile forces, which is nothing but surface tension. Surface tension is nothing but a force acting on a particular length. That is why surface tension is denoted as surface tension. Sigma is force per unit length. Force per unit length. This is surface tension. Now you have somewhat an idea of surface tension. You can refer to any standard book for its meaning or for detailed discussion on it. But we have time limit, so we have to cover maximum amount of things. Next, which was objective question, which was asked: surface tension, what affects temperature and surface tension relationship? So whenever we increase temperature, surface tension decreases. One ESE question, and the next ESE question was surface tension in gases. Surface tension in gases. In gases, surface tension is zero. Why? Because as I already told you, surface tension is because of cohesive forces trying to pull the molecule towards each other, and that tends to resist the tensile forces applied on it. So in gases, the molecules are so far from each other that there is no cohesive forces. No cohesive forces, which results in surface tension 0. These are the engineering services objective questions. Rise in temperature, surface tension decreases. And surface tension is a relative phenomena. You can alter it by either putting on some sort of chemical, anything. Now take a container like this, put on some water in it. Now put on more water until the volume lies here. So what happens? There is a thin layer form over this. The water couldn't drop down itself on its own, but it will form a layer. This is due to surface tension. This is due to surface tension. Now, surface tension, always remember that surface tension is a line force. Surface tension is a line force. It acts always in the perpendicular direction. Surface tension is a line force. Line, remember that word, line force. and its magnitude is given by surface tension given by force per unit length, and this force is a line force. By adding detergent or soap, you can, decrease the surface tension. Now next we are going to deal its mathematical relationships for different profiles. First of all, a general relationship. Suppose a wire bent in the form like this. It's a wire bent in the form like this. And suppose it's a movable wire on it. Movable wire. Now what we are going to do? Just put this assembly inside a solution and remove it. So you got a layer of that solution stick on this surface. You can alter its boundary by moving this movable wire. You can move this either in this direction or this direction, thus by altering its boundary. So suppose at some instant I have bought it in this position, it was 1, it was 2. Now this boundary also lies here, and the increase is dx. Now if I am going to increase this one boundary, so I have to apply a force. Why? Because I am overcoming cohesive forces acting between the molecules. Look at that. Initially the boundary was here. If I am going to stretch away in this direction, what I have to do, I have to just encounter the cohesive forces that is acting in between the molecules. So I have to overcome the cohesive forces, due to which I have to work. So work is equal to force into distance, and that distance is dx. Now as I already told you, sigma is equal to F by L. So F is equal to sigma into L into dx. This is L length. Now L into dx, this gives out the area. So finally we have sigma into change in area. Work done is equal to surface tension into area. Most important relationship I will be using for different profiles for deriving the surface tension of the change in pressures. Now very sort of, you can say, very important topic is work done to convert large drop into n number of droplets. I'll be giving a general relationship. Suppose a big drop, radius capital R, splits into many small number of molecules or drops, n drops. A small big one splits into n number of drops. So what we are going to see, now work done is sigma into area. Now the area that I will change in area will be sigma into, initial the area was 4 pi capital R square minus n times the smaller one, This is the first equation, and the next equation that you will be using is for deriving the relationship between capital R and small r. So the next one is keep the volume intact, constant. Volume of bigger drop is equal to volume of smaller drop. Just equate these equation and you're gonna get the relationship between capital R and small r. So 4 by 3 pi r cube is equal to n times 4 by 3 pi r cube. Using both these equation, you can easily solve a number of problems based on Wakadani converting a large drop of water into small drops of any liquid. So just know the basic concept and apply these in numericals. Now I'll be dealing different profiles, surface tension in the next video. Hopefully you like this video, subscribe it. Thanks.